The James Webb Space Telescope is so powerful that it actually can analyze the chemical composition of atmospheres from far, far away.
When the James Webb Space Telescope finally turned its gaze toward the enigmatic interstellar object known as Oumuamua, the world held its breath. For years, scientists and skywatchers alike had speculated about this strange visitor from beyond the solar system. First detected in 2017, Oumuamua defied easy classification. It was not a comet, not quite an asteroid, and its peculiar behavior raised a flurry of questions. Despite extensive study, all available data until now was based on distant telescope observations made during its brief journey through our cosmic neighborhood. Everything changed when the James Webb Space Telescope, with its unprecedented sensitivity and resolution, revealed the first real direct image of Oumuamua. Before we start, smash the like and subscribe buttons for more updates. This moment marked a milestone in both astronomy and our understanding of interstellar phenomena. The image captured by Webb was nothing short of breathtaking, not because it was dazzling in the traditional sense like a glittering nebula or a radiant star cluster, but because it unveiled secrets cloaked in mystery for years. Where previous images had been mere dots of light or artistic interpretations, Webb provided clarity. The object appeared as an elongated cigar-like body with surface features previously hidden from human eyes. Faint bands of reflective material ran across its length and subtle shadows hinted at texture, perhaps ridges or grooves carved over eons of interstellar travel. The clarity was astonishing. The picture was not just a visual breakthrough, it was a scientific revelation. Oumuamua had always been puzzling. Its trajectory suggested it came from outside the solar system, racing into the inner planets before curving and heading back out at a speed that could not be explained solely by gravitational slingshot mechanics. More confounding was its acceleration, small but undeniable, without any visible signs of gas emissions that would accompany comet-like outgassing. This defied conventional models and theories. Speculations abounded. Some suggested exotic ices sublimating invisibly. Others proposed it might be a fragment of a disrupted planetary body. A fringe but persistent theory even posited it might be artificial, perhaps debris from an ancient alien probe or technology lost to time. Now, for the first time, scientists had visual data that could help separate fact from wild conjecture. Webb's image showed distinct coloring across Oumuamua's surface, with areas reflecting differently, possibly due to compositional differences or exposure to cosmic radiation during its untold journey. There were no apparent thrusters or artificial constructs, at least none visible on the surface, but its shape and reflectivity supported the notion that it was unlike any known solar system object. The elongated structure, while not unique in space, was unusually precise. In fact, the object's symmetry seemed more defined than naturally expected, prompting renewed curiosity about its origin. The material composition gleaned from spectral analysis using Webb's powerful instruments added more layers to the mystery. Certain spectral lines suggested the presence of metallic compounds embedded in a matrix of silicates, perhaps coated with organic residues, compounds that could have formed in the icy outer regions of an alien solar system. Some regions exhibited high albedo, reflecting sunlight with a brightness inconsistent with typical asteroid rock. This implied either a highly reflective mineral or a surface altered by radiation over immense timescales. These clues began to paint a picture of Oumuamua not as a singular anomaly, but potentially as a representative of a larger class of interstellar objects, ones that humanity might encounter more frequently as observational tools improve. The implications of the image went beyond scientific categorization. Seeing Oumuamua in detail transformed it from a dot in the void into something almost tangible. For scientists, it was like being able to examine a fossil from a completely different planet, something ancient, foreign, and filled with unspoken stories. This wasn't just a rock wandering in from space. It was a messenger from another star, a relic from a world that may no longer exist, or one still thriving light years away. Its existence, now confirmed in crystalline detail, underscored just how dynamic and connected the galaxy truly is. Every pixel of the image told a story. The faint streaks of coloration could be the scars of high-velocity impacts with micrometeorites. The slightly asymmetrical tailing edge might hint at material loss during its solar flyby or a rotation-induced reshaping. There was even speculation about layered structures beneath the surface, visible due to faint differential absorption of infrared light. perhaps the result of thermal cycles endured as it traveled through different stellar environments. Webb's suite of instruments working in harmony didn't just capture a photograph. They extracted fingerprints from an object that had voyaged through interstellar space for who knows how long. The sheer improbability of this encounter added another layer of gravity to the image. The cosmos is vast beyond comprehension, and Oumuamua's trajectory happened to intersect our solar system in a window narrow enough that only one generation of astronomers could witness it. That the James Webb Space Telescope was operational just in time to capture such an object felt like cosmic alignment. It was as if the universe had waited for us to develop the tools necessary to peer into its secrets before revealing this celestial traveler in detail. This image also ignited a fresh wave of research and theorizing. With concrete data now available, astrophysicists began reworking models of planetary system formation and interstellar object ejection. If Oumuamua had come from the tidal disruption of a planetary crust, as one hypothesis suggested, then there might be billions of similar objects strewn throughout the galaxy. Some might be traveling through other star systems even now, unseen and unremarked. Webb's image became a Rosetta Stone for interpreting future detections. It would inform how we scan the skies, how we refine our instruments, and how we plan future missions. Even more exciting was the thought that this might be the first step in a new era of interstellar archaeology. With technology like Webb, and with future missions designed to intercept or even retrieve material from interstellar objects, humanity might soon begin to piece together the broader galactic narrative. How matter moves between stars, how worlds die and scatter their remains, and whether other civilizations might have similarly pondered the origin of their own skybound visitors. Webb's image also redefined humanity's relationship with the stars. In seeing Oumuamua with such clarity, we weren't just observing, we were connecting. It was a moment of rare intimacy between our species and the vast universe we inhabit. The object became a bridge, not metaphorically but truly, a solid link between solar systems, tangible evidence that our corner of the galaxy is not isolated. It was a reminder that while we may not yet be traveling to other stars, fragments of other systems are already coming to us. Public fascination surged in the wake of the release. The image was studied in classrooms, discussed in cafes, and shared across social media platforms. For many, this wasn't just an astronomical breakthrough, it was a moment of existential reflection. What else might be out there, traveling silently through space, waiting to be seen? What stories do these wanderers carry with them? Oumuamua was no longer just a name in a research paper, it was a real object, with shape, texture, and substance, and it had visited us. Astronomers also pondered the object's age. Given the lack of cratering or weathering that would be typical in the asteroid belt, some speculated that its surface might be relatively young, perhaps recently exposed. This could mean that its journey through interstellar space had not been for billions of years as once assumed, but perhaps much shorter, suggesting dynamic and ongoing processes in its system of origin. Alternatively, it could have been traveling for eons, its surface continually refreshed by cosmic rays and the abrasive forces of interstellar dust. Either scenario posed fascinating implications for how matter ages in the deep void between stars. The discovery added momentum to the study of interstellar phenomena as a primary focus rather than a peripheral curiosity. Funding discussions began to tilt in favor of missions aimed at detecting, studying, and possibly rendezvousing with future objects like Oumuamua. The image proved such efforts were not only feasible but profoundly rewarding. Just as the Apollo missions reshaped public engagement with science in the 20th century, Webb's image of Oumuamua began to spark a similar cultural and scientific shift. It reignited the primal urge to explore, not just in imagination but with precision instruments and cold data. At the academic level, it opened up cross-disciplinary interest. Geologists began speculating about the object's internal structure, while chemists analyzed spectral hints of exotic compounds. Even biologists took interest, pondering whether complex organic molecules on such objects could play a role in panspermia. The idea that life could be seeded between worlds by cosmic messengers like this one. While there was no evidence of life, the mere possibility that complex molecules could survive interstellar travel elevated the image from a technical feat to a philosophical prompt. It was not lost on anyone that Oumuamua, whose name means scout or messenger in Hawaiian, had now fulfilled that role more completely than anyone had imagined when it was first discovered. Through Webb's eye, it had delivered a message, not written in language, but in form, motion, and elemental makeup. It had shown us that the universe is not static, that the boundaries between star systems are porous, and that we are already part of a galactic dialogue, one that has been going on for billions of years. Even seasoned astronomers admitted to a sense of awe when looking at the image. Not because it revealed a spaceship or a crystalline monument, but because it underscored how little we still know. There is a humility that comes with seeing something truly alien, not in the science fiction sense, but in the literal astronomical reality of it. Oumuamua was not crafted by hands, but by physics, time, and cosmic happenstance. And yet, it felt deliberate in its arrival. Right place, right time, and now forever captured by humanity's most powerful eye in space. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on JWST's first real Oumuamua image? What happens next? We want to hear from you. Thank you for watching and see you next time.